Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome to the coordinate plane. Many of you might be going, the coordinate plane, okay, I get that. Some of you might have heard it as the Cartesian plane. Regardless, it means the same thing. We are going to be dealing with something that has an axis, a vertical axis and a horizontal axis, normally known as x and y. Our x is our independent variable and our y is our dependent variable. Now, some of you may not understand why, but we do have this in 4 quadrants. Generally, this is quadrant 1, and if you are in science class, that's generally the quadrant you stay in. And then mathematicians choose to go up and around, and so it turns out being a counterclockwise motion. So this is quadrant 2, quadrant 3, and quadrant 4. If you line up on an axis itself, that is not in a quadrant, that is on an axis. So please keep in mind that if they ask you about the location, you can tell it quadrant 1, quadrant 2, quadrant 3, quadrant 4, or you can say x-axis or y-axis. So let's say you were asked to sketch the following statement. Okay, so that's saying a lot. Sketch all ordered pairs such that x is greater than 0. Well, so let's think about this. What quadrants is x greater than 0 in? What quadrants is x positive in? Think about your ordered pairs. We've got positive, comma, positive. Quadrant 1 would be good, right? Here we've got negative, comma, positive. That's x would be negative there, so no. Negative, comma, negative, definitely no. And positive, comma, negative. So it's these two, which means our boundary line is vertical. Why is our boundary line vertical? And then of course we have shading. You can kind of scribble, you can get a highlighter. Well, it's because anytime you have an x equals, let's say we have x equals 5. Anytime you go to graph that, it's only going to cross the x-axis because it only talks about x. So you'd have to go to where x is 5 and draw that vertical line, because this is all the ordered pairs: 5, 0, 5, 1, 5, 2, 5, 3. So when it's an x equals equation, it crosses the x-axis. This one just happens to be crossing the x-axis at 0. And think, because we have an inequality, think turn signals. Because we have turn signals, we're shading. Now with x, you can only shade left or right. For all the others, we're going to talk about a different way of shading, and that would be up, down. So anything that slants, we can do up, down. Up being greater, down being less. And I've told my students that a less than looks like a left turn signal, and to get your left turn signal to turn on, you have to push down. So that's why less than you would color down. Whereas greater than looks like a right turn signal, and to get a right turn signal to come on, you would have to push up. So that's greater than or up. So that's why we have right turn signals as well. So you can think of them as blinkers or turn signals. Now, these would also be underlined because the boundary line was included or solid. Remember, if the boundary line is not included, you would have dashed lines, meaning, hey, you can get almost to here, just don't actually get to this point. Okay, so let's, if it's linear, our graphing calculator can graph it. As long as it's a function, well, actually, as long as it's a function, our graphing calculator can graph it. If it's not a function, our graphing calculator has trouble. So what if our sketch was all ordered pairs such that y equals 1? Okay, in this case, there's no turn signal, so there's no shading. It's just an equal sign. So in this case, y equals 1. Well, it only mentions y, so it's only going to cross the y-axis, and it's only going to cross the y at 1. So every ordered pair here has a y value of 1. That's all that's saying. Graph it to where all the y values are 1. This one could be graphed with your graphing calculator. Again, because most of our graphing calculators are going to be in a function notation. So when we come in here, y equals 1. Absolutely. So what about all ordered pairs such that the absolute value of y is less than 1? Oh, well, in my graphing calculator, I can't put the absolute value sign on y. I can only put it on x. So that tells me this is not going to pass the vertical line test when I get the picture done. Okay. However, we have learned in other videos that in order to drop the absolute value sign, we have to do it once as a positive and once as a negative. But we only graph by making them. So let me flip that. Okay, y is greater than negative 1. So I'm going to graph this first one in green. So here's where y is 1. Less than means we down, or it's a left turn signal, so we'd have to shade down. So we shade down from it. I'll graph this one in orange, so negative 1. And they're dotted lines because it's not underlined. So I cannot actually get to either of these lines. And that's a right turn signal, and the way you get the right turn signal on in your car is you shade up, or you color up, push up, right? So there is one section that agreed in both of these, one that is orange and green. And so that's your answer. And there's no way to do these without inequalities a lot of times when it includes x and y in the problem without graphing. So basically, the distance from y is less than 1 unit. Would you agree that everything shaded is less than 1 unit from y? The y value is less than 1? Yeah. Not from the y-axis, but. So again, when you start graphing, make sure that you understand whether it's greater than, less than. If you have to do extra shading and you have two things going on, make sure that you double check where your shading overlaps. With the coordinate plane and graphing comes a lot of other questions. For example, distance. Okay. P is at 1, negative 2. And Q is at 8, 9. Is A, 5, 3, closer to P or Q? Justify your answer. Okay, well, closer means less distance, right? So we have to know a distance formula. Really? Do we have to know the distance formula? Do you know the distance formula? Okay, so I'm going to explain to you why we can do the distance formula, or we can just not do the distance formula at all. So for those of you who remember, the distance formula is equal to this right here. But I don't know that I've ever had a class where everybody has the distance formula memorized. I don't. However, I have come to classes where it was like P is at 1, negative 2. A is at 5, 3. And I've seen students do this. 1, 2, 3, 4. 1, 2. 1, 2, 3, 4, 5. Oh, a squared plus b squared equals c squared. (16 plus 25 is 41. And they just do the Pythagorean theorem. Okay, well, let's check out what happens if I use P and A and I do the distance from P to A, right? x2 minus x1, so 5 minus 1 plus 3 minus negative 2. 4 squared plus 5 squared. Wait a second. Isn't that what I got? Absolutely. The distance formula is just a rewritten version of Pythagorean theorem. If you don't want to memorize the distance formula, you don't have to. You can use Pythagorean theorem 100% of the time. There's a relationships there. So it's up to you to choose which one's going to work best for you. Okay, so now we know P to A is the square root of 41. So what about Q to A? Well, Q is sitting over here at 8, 9. And this, remember, was at 5, 3. So we'd have to go over 3 and up 6. And we're seeing that right, 5 to 8, 3 to 9. And could you actually use graph paper? Yes. So we're just getting Pythagorean theorem for that. And again, remember this one was P to A. So this one is A to Q. So we've got 3 squared plus 6 squared is going to equal our c squared. So 9 and 36, that's going to make 45. So which one's smaller? P to A or A to Q? I'm getting P to A, which means A and P are closer together than A and Q. So is A closer to P or Q? It's closer to P. And a lot of times in math, you can utilize your algebra right there as your justification. The square root of 41 is smaller than the square root of 45. Great, let's think about this again, something else now. P is at 1, negative 2. Q is at 8, 9. Where's the midpoint? Okay, well, you can memorize the midpoint formula, or you can think about it logically. What is halfway between 1 and 8? Can you visualize that? If you said it's 4.5, you're correct. And what's halfway between negative 2 and 9? If you said 3.5, you're also correct. You probably did the midpoint formula without realizing it. The midpoint formula just takes your two x values and averages them. Then it takes your two y values. Whoops, y2. I wrote negative 2 because that was my y. And averages them. I could have written, I should have kept this the same, 1 and 2. There we go. So your midpoint formula is just averaging your x, averaging your y's. You can really think about that one pretty logically. And your midpoint's not always going to work out to be some special, perfect ordered pair every single time. And then I also tell my students that anytime they're graphing for me, things that you must see are any intercepts. I don't care if it's a decimal, a fraction, a radical. Make sure any intercepts show up. So that would be any x, 0 and any y, 0, y that would exist. Always make sure that you clearly draw any asymptotes. And if you don't know what an asymptote is, you can go back to my graphing rational functions. And you also need to know any end behaviors. you need to be able to clearly see where are the arrows going. So make sure that anytime you're giving a graph, you know exactly those things. So let's say you were tasked with graphing y equals x squared minus 2. Well, if you've watched enough of my videos, you know that x squared is a parabola. And therefore it makes a happy face because the a value is 1. So that tells us that as x goes to the left and as x goes to the right, it doesn't matter, both directions, y is going in a positive direction. So that's what these arrows are doing. There's no dividing by variables and there's no square root symbols, so there's no domain errors. So our domain is all reals. So really, once we get our intercepts, we should be good to go. So the easiest one always to get is your y-intercept. Some people forget how to get a y-intercept, but remember, what we're really asking in a y-intercept is, if I made a table of values, 0 for the x, what is y? So substitute 0, 0 squared minus 2 is negative 2. Now for the x-intercepts, we want 0 to be the outcome. We want it to be the y. So let's actually work that one out by hand. And if I were to solve this, I'd add 2. And then I'd square root both sides, plus or minus the square root. The square root of 2 is a decimal. It's bigger than 1, smaller than 2. So I would encourage you to clearly label this as root 2 comma 0 and negative root 2 comma 0 when graphing, so that we can clearly see what's going on in this. And it makes a parabola, which is symmetrical, so that's a nice thing as well. Circles. I find these to be one of the hardest things for students, and I'm not completely sure why. So let's just kind of go over some stuff with a circle. Let's assume we have a circle centered at the origin, because that's what a parent function would be, right? And we have a circle. And if I were to draw this right here, this would be the radius of the circle. And this is an ordered pair x comma y, meaning we have to come over x and up y, if I can draw that well, which results in a right triangle where the legs are x and y respectively. So what relationship do we see between x, y, and r? Well, we see that x squared plus y squared would equal the radius squared. That's Pythagorean theorem, right? However, what if I took that same circle and I shifted it? It has the same r, but now it's been shifted to the right and up. Well, that's that HK shift, right? And if you've watched videos about transformations of functions, you've done HK shifts. So all the formula for an equation of a circle is this Pythagorean theorem with an HK shift. That's all this is. The x has been shifted by your h, the y has been shifted by your k, and therefore now we have the equation of a circle. Again, it's Pythagorean theorem combined with HK shifts. Okay, so let's see if we can't get this going. You are going to have the equation of a circle, and I'm going to do this on graph paper. So find the equation of a circle passing through endpoints of a diameter located at 1, 8 and 5, negative 6. Okay, that's a lot of information, right? So let's just go ahead and let's just graph this out. All right, a little zoom going. So 1, 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. So we've got a circle, right? I'm not the best at freehanding circles, so keep that in mind. We've got our circle. This is our diameter. So we've got to find our center of our circle. Well, wouldn't our center of our circle be our midpoint? So what's halfway between 1 and 5? 1 plus 5 divided by 2, that would be 3. And what's halfway between 8 and negative 6? So 8 plus negative 6 divided by 2 is 1. So our midpoint's at 3, 1. So hopefully I freehanded well. 1, 2, 3. Hey, not too bad. There's our center. So our circle is not centered at 0, 0. It's centered at 3, 1. So the first thing I'm going to do is x minus h squared plus y minus k squared equals radius squared, right? That's that formula we talked about, our hk shifts. We've been shifted 3 to the left and 1 up. And the reason why it's the opposite in both parentheses is the same reason why when we grouped it with x during h that it was the same. So now all I need to get is my radius squared, because again, this is Pythagorean theorem, correct? So now, because we graphed it on graph paper, finding out our radius is not hard. You see this is 2, and we've got 1, 2, 3, 4, 5, 6, 7, right? Yeah. Okay, so now we can do Pythagorean theorem to get our radius. So 2 squared, which is 4, plus 7 squared equals our radius squared. Do we actually need our radius, or do we need our radius squared? We need our radius squared. So 4 plus 49 is our radius squared, so 53 is our radius squared. So we're just going to pop 53 right in there. So again, this is like Pythagorean theorem, a squared plus b squared equals c squared, just with an hk shift. Now, if you're given an equation and you have to find the center of the circle and things like that, that might be a little different. You might have to complete the square, and if you need help on that, I do have a completing the square video. The other thing you might be asked about is symmetry. We have what's known as even symmetry. And even symmetry means it folds on the y-axis. Not any other axis, the y-axis. So if you check any x value and its opposite, the y should match. For example, 2 and negative 2. 2 is at positive 3. Negative 2 was also at positive 3. So it didn't matter whether I checked positive 2 or negative 2. The y's matched. We also have odd symmetry. Odd symmetry means for any A or negative A, any A and its opposite, these are opposites. For example, 3 is at -1, -3 was at +1. The other thing that they call this is symmetric to the y-axis, and they'll call this one symmetric to the origin. Okay. They also have symmetric to the x-axis. However, if you're symmetric to the x-axis, you're not a function. So it doesn't have a special name like even function or odd function because it's not a function. So this would be symmetric to the x-axis because it folds on the x-axis. So in order to check that one, you would have to check, you would substitute a y value and the opposite, and then the x's must match. So you can use a table of values to check for symmetry of any kind. This example would be like x equals y squared, whereas over here it would be y equals x squared. So see how the squaring happened on the opposite variable? And so that's why this makes a parabola that is symmetric to the y-axis, where this makes a non-function that is symmetric to the x-axis.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.